This video is going to be about gas stoichiometry, and we're going to do some practice together. Let's revisit this little map that we have when we first started learning about stoichiometry. Remember that this map really had two parts to it, a given side and an unknown side. And so whenever the given was in perhaps grams, for instance right here in grams, we were able to convert to moles by dividing by the molar mass. And then remember, we could go mole to mole by multiplying by the mole ratio. And then we can go moles to grams by multiplying by the molar mass. So this part of the map you are very used to. Now we're going to add this liters to moles part down here. And as I explained in the previous videos, we know what we can do when we need to go moles to liters. If we need to go moles to liters and it is at STP, well, that's easy. We're just going to use the 1 mole equals 22.4 number, okay, or the molar mass. If it's not at STP, we're going to have to use the Pervnert. Okay, so we're going to have to use PV equals nRT. Now these two situations, the molar mass, or the molar volume of a gas, and the Pervnert equation, those are going to help us interchange between moles and liters. And of course, you know what to do if you want to go liters to liters, that you would just use the liter ratio. And again, if we're going to go liters to moles, if it's at STP, we're going to use that 22.4 number. And if it's not at STP, we got to use Pervnert. Now this is a lot to take in, but with a little bit of practice, we'll get it. We are going to begin with worksheet number 1. We're going to do it together. So we want you to get out some paper and write down the equation for number 1 and go ahead and balance it. I think you should have these coefficients, 2, 3, 1, 3. 2, 3, 1, 3. All right, so now we have our balanced equation. The next thing that you need to do is to write down the given and the unknown. And so in number 1, it says that we have a 115 gram piece of aluminum, which is added to sulfuric acid, and they want to know how many liters of hydrogen gas is formed. How many liters that is formed. All right, so let's just make a plan first before we get going on this. We have to go grams to liters. And according to that map that I showed you earlier, here's what it looks like. You take grams, and we have to take this grams, and we have to change it to moles. Once we change it to moles, we can change it, that mole, to mole of the new substance by multiplying by the mole ratio. Once we get to moles, we can go up to liters. And remember, there's two ways. You either use Pervnert, or you can use the 22.4 number. Well, in order to use the 22.4 number, we need to know if it's at STP, and it is at STP, yes. So we're going to write STP right here to remind us that when we get to that portion, we're going to use the 22.4 number. All right, so now we're ready to calculate. So we're going to write the given down, 115 grams of Al, and when we're done, we have to change that into liters of H2. All right, so let's follow our plan. Our plan says take the grams, and change them to moles. All right, we know how to do that. We divide by the molar mass of aluminum. So we look up aluminum on the periodic table, and we notice that it's 26.98. So 26.98 grams of aluminum go down here, and that's how many are in 1 mole of aluminum. All right, so we've now gone grams to moles. Now we need to go moles to moles. All right, we know how to do that. That's the mole ratio. So since we have a balanced equation, the mole ratio looks like 3 moles H2 over 2 moles of Al. All right, now we're done with the mole ratio. So now we have to take the moles and go up to liters, moles up to liters. And it's at STP. All right, if it's STP, that means we get to use the 22.4 number. So we will have 22.4 liters of hydrogen gas occupies 1 mole at STP. All right, so we are ready to go. We just have to multiply all these numbers. 115 times 3 times 22.4, and then press equals and divide it by 26.98 times 2. And I believe that you will get as an answer around 143. All right, so let's look at the plan again. We had grams, we have to change them to moles. We did that by dividing by the molar mass. Then we go moles to moles. We do that by multiplying by the mole ratio. After that, we need to take our moles and change them to liters, and since it is at STP, we can use the 22.4 number. And there we have now converted 115 grams into 143 liters of hydrogen gas. In number 2, it doesn't directly say, but they want you to use the same equation. Okay, so we're going to use the same equation, but we're going to have a new given. The new given is going to be 2 liters of hydrogen gas. So we're going to start here with 2 liters of hydrogen gas. And it wants to know how many grams of aluminum was used to produce 2 liters. All right, again, let's make a plan first before we start doing the calculation. We know if we have liters, we always have to go to moles. And once we go liters to moles, we can use the mole ratio to go moles to moles. And after we get to moles of the new substance, we can go up to grams by multiplying by the molar mass. Okay, so this is our plan. We're going to take liters, we're going to change them to moles to moles, and then moles to grams. Next thing we need to know is this at STP? So when you're looking at number 2, it doesn't say anything about STP, and in fact, it gives you a pressure and a temperature. So that's an indication that you need to use PervNert. All right, so we're going to have to use PervNert in our first conversion. PervNert. So go off to the side, and the very first thing that you're going to do is going to use PervNert. What's the purpose of PervNert? It's to take the volume, and change it to moles. So in this equation, we're going to solve for moles. All right, so we're going to use the numbers that they gave us. The pressure was 1.25 atm, so 1.25 atms. And the volume was also given in the problem as 2 liters of hydrogen. And remember, we're solving for moles, so we'll just leave N in there. Then you have to decide on the R. Well, this is atm, so the R is 0.0821. And then the last thing that you need is the temperature, and do not forget it must be in kelvins. So 27 degrees Celsius is equivalent to 300 kelvins. All right, so now we're ready to solve for N, and so when we're done, we'll get N is going to be equal to 0.1 moles. 0.1 moles. And that's 0.1 moles of H2. How do I know? Because the given was liters of H2, and all I did was go down here and change it to moles of H2 by using PervNert. I had to use PervNert because the pressure and the temperature was not STP, so you have to use PervNert. All right, so now basically we are right here. And so we have to go from here to here and then up to grams. All right, that's not a problem for us. We know how to do that. All right, so let's start with our 0.1 moles, H2, and we're going to, in the end, we're going to change that to grams of aluminum. All right, so we are at moles right here. We have to go to moles over here. That's the mole ratio. So we are going to have 2 moles of aluminum over 3 moles H2. All right, so now we're here, and we got to get up to grams. We have to go to grams of aluminum, and so we need the molar mass of aluminum, which is 26.98 grams of aluminum, and that's in 1 mole of aluminum. So let's check to make sure all of our quantities cancel out. Moles and moles of aluminum cancel out. Moles and moles of hydrogen cancel out. And so we are ready now to take 0.1 times 2 times 26.98 divided by 3, and we should get a number that is very close to 2. So you're either going to get 1.8, or sig fig that up to 2 grams. So let's look back one more time what we did. We were given 2 liters, but it was not at STP, so we first used Pervnert. So we first did the Pervnert equation right here, and we converted 2 liters to moles. We get moles. Then we used that quantity to change from moles to moles, and then up to grams. So we would need mole ratio, then we would need molar mass. So we have mole ratio, molar mass, multiply them out, you get 1.8. Now we're going to do number 3, and this is the last one I'm going to do because now I will have given you one example of each kind. In worksheet number 3, this is the combustion of ethyl alcohol, and so there's the equation, and I went ahead and balanced it for you. Next step is to write down the given and the unknown, and so in question number 3, the given is 6.25 liters of oxygen, so 6.25 liters of oxygen. And it says at STP, and they want to know how many liters of CO2 gas would be formed. So they want to know this question mark in liters. So when you step back and look at this, you can see that this is a liters to liters problem, liters to liters. Well, remember that liters to liters, you use the volume ratio, so you can't get much simpler than this. So we're ready to roll on this one. And we're just going to use the liter ratio that, remember, is very much like the mole ratio. And so we start with 6.25 liters of O2. And when we're finished, we need to change that to liters of CO2. Liters to liters, use the liter ratio. Liters O2 goes on the bottom. Liters of CO2 goes on the top. We use the balanced coefficients, so we get a number 2 for that and number 3 for there. And we are ready to calculate. And so 6.25 times 2, then divide by 3, you would get a number that is pretty close to 4.17 liters. 4.17 liters. All right. I have given you an example of 3 kinds of gas stoichiometry. We did one that was at STP. We did one that is not at STP. And then we did a liters to liters problem. These are the basis for all of the conversions, and I think that with your knowledge of stoichiometry, you can figure out how to do all of the rest. So I would like you to go ahead and do the rest of the paper, and I will see you tomorrow.